All right, guys, here we go. Here we go. So we're gonna start again. I think we're good, but just in case. So it says, all right, let's start by finding the derivative of e to the x. The one property that we will be using is this one, and we know that the derivative of e to the x is e to the x. So how though? And I guess I should have put a question mark right here. So let's prove that. So we're using the definition of derivative. So let me write f of x equals e to the x. And I'm going to write f prime of x equals limit as h approaches 0. And all I'm doing is using the definition of derivative, right? So I'm doing, I guess I'll write it first. F of x plus h minus f of x all over h. Are we still okay? Okay, so that's my definition of derivative. I'm going to plug in. I already know that f of x is e to the x. Let me write what f of x plus h is. F of x plus h equals e to the x plus h. And x plus h is an exponent. We're still okay? Oh, maybe I can raise this up. Oh, no. That's all it goes. Sorry. And no demerit. I mean, no yawning. That's a demerit. No demerit. LOL. Limit as h approaches 0 of e to the x plus h minus e to the x all over h. Are we still okay? Okay. I'm looking at this guy right here, and I'm using my law of exponents, and I can rewrite that. I'm going to put an equal sign. I'm going to write limit as h approaches 0. I can rewrite that as e to the x times e to the h minus e to the x all over h. And I'll wait for you guys to catch up.
You're just breaking it down?
Yep, I'm just breaking it down. Not like dancing when you break it down.
Right.
All right, sorry, I won't do that again. Equals. You should have seen Kyle. This Kyle was like, limit. Sorry, miss. You reminded me of that meme. Have you seen the meme of like the kid's like a little 3-year-old and she's like, oh, looking. Yeah, do you guys know what I'm talking about? That's exactly what she reminded me of. Hey, no yawning. That's another demerit. How many demerits are you going to get today, miss? Here we go. I'm going to factor out an e to the x. So there's my e to the x factored out. E to the h minus 1. All this is over h. Are we still okay?
Yes.
Okay. This e to the x is not being affected because this is h approaches 0. So I can use my limit properties and put that in the front right here. So I'm going to rewrite this as e to the x limit as h approaches 0 of e to the h minus 1 over h.
Okay.
What did we just say about that limit right there in brackets? It's 1. So I'm going to have e to the x times 1, which is just e to the x. So there it is. So finally, d dx of e to the x is just e to the x. That's the only derivative that is like that. If we're using chain rule, so here it is. Here's chain rule. So they're telling you that u is differentiable function of x. What does that mean? That means it's just u of x. That does not mean u times x. It's just that u is differential with respect to x. So chain rule, derivative of e to the u is itself, e to the u times du dx. That's all it means. So that's cool or not cool. So all we're doing today is we're just going to take the derivative of exponentials, this one and the other one, the base, different base. Don't worry, we'll cover it when we get there.
E was raised to the power of 4.
Well, that's a constant. If it's just e to the fourth,
That's just
a constant.
Okay.
So the derivative will be 0. You know what I mean?
Yes.
So check it out. All we're doing is practicing, and then we'll do the one from the AP exam. I got 2 of them in here actually from an AP exam. Dy dx, if y equals e to the x plus x squared, then I'll wait for you guys because I can hear the shuffle. Oh, sorry, Spider-Man. Dy dx equals itself e to the x plus x squared times, I got to do chain rule. What's the derivative of x plus x squared? 1 plus 2x. Leave it alone, or move the 1 plus 2x in the front. It does not matter. How do we feel?
Wait, that's just beautiful.
That's it.
Like, that's it.
That's it.
Why don't we do it? Stop the cat.
Because there is nothing else. There is nothing else to take a derivative of. It's just, e to the u times du dx, and the derivative of like your u here on this is x plus x squared.
So unless it's a constant, the e still getting present when we take the derivative.
Okay, say it again.
So unless the power, so like.
Yeah, because you said last time, what if I have e to the 4? Well, that's a constant, so that's 0.
So unless we have e to the power of like a specific
A variable.
variable, e will still be present in the derivative. Like if we have like x squared or x cubed, like e will still be
e to the x squared times 2x.
So e will always be present still, unless it's a constant.
Yeah.
Okay.
If it's a constant, just no, you're good. You're good, miss. All right. Do you guys think we're ready for number 12 or no?
Yes.
Okay, give number 12 a shot, guys. That's from the 2008 exam. No, give it a shot. You got this.
Oh, that was the year I was born. What?
Almost all of you were born in 2008. Some are maybe 2007 or 2009. Maybe. All right, we're 20.
She's not a senior. Oh.
All right, guys.
I don't know how to do this. I got this.
Yes, you do. Yes, you do know how to do it.
We got this. Oh. I thought I had it integrated.
I'm doing chain rule, guys. How many got A? Let's do a tally. How many think it's A? How many think it's B? How many think it's C? How many think it's D? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. How many think it's E? How many are not sure? I guess 1, 2, 3. Okay, 3 unsure. Well, this is not everyone in the class. We're missing like 4 of you because there's 1 absent. All right, so here it is, guys. So this is like if this 2 to the x is like your u, right? So if I bring that x up, that's 2x to the negative 1. So when I'm doing the derivative of this, f prime of x, you're going to go itself, e to the 2 over x, times the derivative times du dx, so times the derivative of this guy. So what's the derivative of that? Negative 2x to the negative 2. So 2 times negative 1 is negative 2, x to negative 2. So there it is. You're done. Now you're just doing algebrate. Now you're just doing arithmetic. Algebra, some arithmetic. So let's see. This is in the numerator, negative 2 e to the 2 over x. And then that x to the negative 2 goes down. So x squared. Now let's look for that answer. And yeah, you guys were right. Letter D. So let's see, the 5s, 89% of the 5s got it right, 79% of the 4s, 69% of the 3s. So pretty much everyone who's qualifying is getting this question correct. What's up? You can. Like for 2 to the 2 over x, you can, but I think it might be overkill. Like look, let's say u is 2 over x, so du dx equals bottom, derivative of the top, minus top, derivative of the bottom, all over bottom squared. And notice you will get the same answer, but I just think it's easier to use power rule. You know what I mean? Unless you don't think it's easier. You don't think it's easier? But know that you can use power rule. All right, here we go. Let's see if I won't mess up this time. I won't. All right. So what about an exponential function other than base e? Real quick prerequisite. Do you guys know that? I guess let's just talk about what we should know, or what we should more or less know. So we know that y equals ln x and y equals e to the x are inverses of each other. Chop, what does that mean? That means that if I do something like e to the ln of a, you just get a. Or if I do something like ln of e to the power 5, you just get 5. Using the power rule, bring the 5 up. That's what it means, that they're inverses of each other. I guess you could also say e to the ln of x equals x. E to the ln of x equals x. Or these are all things from the past. Don't worry, we're going to go slow. Let's see, what else? ln of e is equal to 1. So we're not doing calculus yet. I'm just doing some properties. And I guess for now that's okay. Are we okay? All right. So notice I wrote here a to the power x, and then notice what they did here. They went e to the ln a to the power x, and then they're just, oh, by the way, power rule. If I go ln of a to the power x, this is just a power rule for logs. I can move that x to the front, and that's x ln of a. Does that make sense? And let me erase this dot here because I don't want to get it confused for multiplying. So that's what they did here, a to the power x. And why did they do that? Why did they do that? Because the only thing we know right now is how to take the derivative of e to the power x. Yay or nay? Yay. So having said that, I can rewrite this. It says d dx of a to the x is the same thing as d dx. That just means take a derivative with respect to x of e to the, and look, a to the x is the same thing as this. So e to the x ln of a. So do that. Let me write a side note here. ln of a is a constant. Are we still okay? Okay. And I'm going to go slow. Is anyone confused? Is everyone okay? Okay. All I'm doing is this, guys. All I'm doing is this right. Where's my chain rule? All I'm doing is this right here. Okay, that's all we know. So the derivative of e to the u is e to the u du dx. So the derivative of this is itself e to the x ln of a times, I got to take, okay, I'll slow down. I got to take the derivative of my exponent. Notice that your exponent is a linear term. ln of a is a constant. So I can just drop the x. The derivative of x ln a is just what? ln a. Oh. Yeah, okay, don't worry. Oh, I understand. Yeah. I understand. Because it's just x. Yeah, and look. X would be 1. Y equals x ln a, or maybe I'll start with this one. If y equals x ln a, what's the derivative of that? ln a. Chav, I don't get it. Y equals pi x. What's the derivative of that? Pi. It's just a linear term. It's x times ln a, so you just drop the x. Okay. Does that make sense, guys? Okay. Now this right here, x ln of a, look, I have it right here, is just the same as what? A to the x. So I'm going to write d dx. Yeah, it's ln of a times x. It's just a constant attached to x. A to the x, ln of a. And there it is. That is that. And now we got a definition. Now we got a definition. So what's my definition? Don't worry, we're going to practice. My definition, if I have chain rule, the derivative of a to the u, and u has to be differentiable with respect to x, is going to be itself, a to the u, times what? ln of a, whatever that base is, times chain rule du dx, derivative of u with respect to x. We're about to practice a whole bunch. Don't worry, I changed it. Remember last time we did an example already trying to find the slope? No, let's just practice taking derivative. That's it. That's all we're doing. You get no. I think about how to write this, guys. I put a lot of thought into this. All right. All we're doing is practicing taking derivative. That's all we're doing. All right. What's the derivative of 2 to the power x? 2 to the power x times ln of 2. And then du dx, the derivative of x is just 1. So do I have to show anything? No. There it is. That's it. Cool or not cool? Yeah, that's what we're doing a whole bunch. Yeah. See, this is like a is like my 2. So derivative of any exponential is itself. And if it's not e, you got to do ln of a. If it were e, you'd be done. Why? Because if it were e, it'd be ln of e. And ln of e is 1 anyways. No. This is 2 to the power x. It is. You're right. It is chain rule. Eventually, like derivative of the x is 1. But remember, derivative of any exponential is itself. And then ln of the base. And then du dx. Whatever the exponent is, you got to take a derivative.
So we always keep it and then find.
And then ln of the base. And then du dx is the derivative of the exponent.
And is ln find the derivative or no? Or is
No,
it just
that's
changing?
it. Check it out. Ready, Houston? What's the derivative of 7 to the power x? Follow this.
7 to the power of x ln 7
times 1, which you don't need. There it is. Does that make sense, guys?
Yes.
Okay, all we're doing is just using the definition. All right, notice on this one, my exponent is not an x. My exponent is 5x squared. So we're going to have to do chain rule. Hey, no, that's another demerit. No, we're good. So here we go. The derivative of this is an exponential function. It's going to be itself. 4 to what power? Perfect. Am I done? No. Then I write what? ln of 4, because that's the ln of the base, times 10x. Good. There it is. Leave it alone. I mean, I guess you can write 10x in front of the ln of 4, but you don't mix it with the 4 there. You're not going to say 40. That's not how this works. Leave it alone. Cool or not cool? Cool.
So it's basically like the ln is for the derivative base.
Yeah.
And then the 10x derivative exponent?
Yeah.
Oh my goodness. Okay.
By the way, guys, I want you to just make a note. Look at this. I guess we'll make something up really quick. If I were to use the same rule for e to the x, because e to the x is an exponent, let me write e to the x squared. Look at this. E to the x squared. If I were to use this rule, ln of, I guess I'll write e to the x squared there. ln of e, sorry. I don't know. I said ln of the base times 2x. What's ln of e? Look at that. And you still get that's why we don't write times 2x. That's why we don't care about because it's ln of e. Like, that's why we don't use it, because ln of e is 1 anyways. Like, you know what I mean? So it still works even if you were to use it for that. Yeah, sorry for almost confusing everyone there. I took it out before I did too much damage. Are we okay?
Yes.
Yeah, it's always ln of the base. That's it. So look, it worked. Okay, ready for letter D?
Yes.
What do you think, mechanic? We're doing okay? Okay. So the derivative of 5 to the power sine x is 5 to the sine x itself times ln of 5 times, there it is. Are we okay? Yeah, try the next one. You already did it, Ms. Cruz? Too fast, too furious. I haven't seen it.
My favorite's the second one.
I just know that diesel guy always says family. Family. All right. Derivative. Derivative is itself 3 to the cosine squared x times ln of 3 times 2 cosine x times, yes. Good job. Chain rule. It's a triple link. I'll in case you want to right here on the side, d dx, giant parenthesis, little parenthesis, cosine x, close, close, squared, close. See? 2, leave the inside alone, times negative sine x, if you wanted to see it. Okay. From the 2019 exam. This is an actual question. Do you guys have your tablets? Oh, man. I guess you don't need them, but I would like to take data from this, see if you guys can get it right. I'll tell you what the percentage is. I don't know off the top of my head. I'd have to look it up. Yeah, I guess so. Yeah, let me create this activity real quick. Form activities. So use your phones just for this one. Activate. Okay, so go to polev.com/chav, and I was going to put the QR code up there, but well, I guess you know what? Here, you can get the QR code. It's right there. Can you guys see it? Scan the QR code and it'll take you right to it. And then answer this question. Take another 30 seconds. Make sure you at least answer the questions to give you a participation grade. Watch out, mechanic. Did you answer it, Rodriguez? Or sorry, did you answer it, Spider-Man?
Yes.
All right, there's 2 of you that haven't answered it. Make sure you answer it, guys. All right, let's see what most of you put. Responses. So almost all of you put D, a few of you put A. So let's see. I'm going to go ahead and close it up. Oh, did you guys the last 2 just pushed D? All right. So let me go ahead and stop presenting. So let me, you guys are funny. All right, so let's see. So they wanted the derivative of this. So what's the derivative of x to the 5th? 5x to the 4th. And then minus, what's the derivative of 5 to the x? 5 to the x. ln of 5. There it is, that's it. So let's look for that. 5x to the 4th minus ln of 5, 5 to the x. You guys got it right. Cool or not cool? All right. And that's it. Now we're just practicing. So do you guys feel pretty good about this? All right. Let's practice. It's on Delta. And that's it. Let me know where we have issues and we'll go from there.